wonderful learners. You are welcome to today's class. And today's topic is indices. And under it, we are going to consider exponential equation of linear form. And we are going to evaluate all the examples given. We are going to solve them together. So let's start. In question 1, solution. In question 1, we have 3 raised power s is equals to 1 over 81. Don't forget that we are going to express 81 in index form. We are going to express it as the product of its prime factors in index form. And that will be 3 raised to power 4. So we are going to have 3 raised power s is equals to 1 over 3 raised power 4. And don't forget that in indices, when we have 1 over 3 raised power 4 like this, it's going to give us 3 raised power minus 4, according to the law of indices. So this 3 will eliminate this 3 here. Therefore, s is equals to minus 4. Let's solve question 2. We have 3 raised power minus y is equals to 243. We are going to have 3 raised power minus y. So we are going to express 243 as a product of its prime factor in index form. And that will be 3 raised to power 5. So this 3 will eliminate this 3 here. Minus y is equals to 5. Therefore, y is equals to what? Minus 5. Let's solve question 3. We have 25 raised to power minus 5n to be equals to 625. So we are going to express 25 as a product of its prime factor in its index form. That will be 5 raised power 2. Don't forget that we have raised power 5n here. Is equals to, we are going to express this 625 too as a product of its prime factor in index form. And that will be 5 raised to power 4. 5 raised to power 4. 5 times 5, that's 25. 25 times 5, that's 125. Then 125 times 5 will give us 625. So we are going to have 5 raised to power 4. And don't forget that this power will multiply each other. So we are going to have 5 raised to power minus 10n to be equals to 5 raised to power 4. This 5 will eliminate this 5. So therefore we are going to have minus 10n to be equals to 4. And n here will be minus 4 over 10. Don't forget that I corrected it the other time that your minus must be in the numerator side. So we are going to reduce it. We are going to have minus 2 over 5. Let's solve question 4. In question 4, we have 4 over 2 raised to power x to be equals to 64 raised to power x. So here we are going to have 2 raised to power 2 over 2 raised to power x to be equals to 64 here. That's 2 raised to power 5. Don't forget that 2 times 2 is 4. Multiply by 2 will give us 8. 8 times 2 will be 16. Then 16 times 2, that's 32. 32 times 2 will give us 64. So 64 is 2 raised to power 6. We are going to have x. Right? So we are going to have 2 raised to power 2 over 2 raised to power s to be equals to 2 raised to power 6 times x. That will be 6s. And here, when we have 2 raised to power 2 over 2 raised to power x, don't forget that we can express it. So we are going to have 2 raised to power 2. Don't forget, according to the law of indices, if you have the same base, different powers, by the time this one wants to come, it will be negative. So we are going to have 2 raised to power 2 minus s to be equals to 2 raised to power 6s. And these 2 will eliminate these 2. So therefore, 2 minus x is equals to 6s. And we are going to simplify for that. We are going to collect the like times. Collect the like times. Then we are going to have 2 to be equals to 6s plus s. 2 is equals to 7s. 7s is equals to 2 and s is equals to 2 over 7. So let's solve question 5. Let's solve question 5. We have 0.25 raised to power s plus 1 is equals to 16. The first thing that you need to do here is to express this decimal number in a fraction form. 0.25 in a fraction form will give us 25 over 100. raised to power s plus 1 is equals to 16. We are going to reduce 25 over 100 to its lowest term. 25 in 25, that will be 1, and 25 in 100 will give us 4. In bracket, raised power s plus 1 is equals to 16. And we are going to express this 16 as a product of its prime number in index form as well. And the same thing is applicable to this 4. So we are going to have 1 over 2 raised power 2 in bracket. In bracket, raised to power s plus 1 is equals to 16 will be 2 raised power 4. 1 over 2 raised power 2 in indices form will be 2 raised power minus 2. Don't forget, in bracket, raised power s plus 1 is equals to 2 raised power 4. So by the time we open the bracket, we are going to have 2 raised power minus 2s. Minus 2 times plus 1 will give us minus 2 to be equals to 2 raised power 4. And don't forget that these two will relate each other here. So therefore, minus 2s minus 2 is equals to 4. Minus 2s is equals to 4 minus 2. Minus 2s is equals to 2. And s will be equals to minus 2 over 2. And this will give us minus 1. So let's solve the last question for today, number 6. We have 10 raised power x to be equals to 1 over 0.001. This will be 10 raised power x is equals to, don't forget that this 0.001 could also be written in indices form. We can write it in a fraction form first. That will be 1 over 1000. 0.001. That is equivalent to what? 1 over 1000 in a fraction form. So we are going to have 10 raised power s to 1 over 10 raised power minus over 3. Don't forget that 1000 will be 10 raised power 3. And by the time you express this further, we are going to have 10 raised power x to be equals to 1 over 10 raised power minus 3. 1 over 10 raised power 3 will give us 10 raised power minus 3 in indices form. So we are going to have 10 raised power x to be equals to 10 raised power 3. By the time you eliminate it, therefore, s is equals to 3. I want you to try the following examples, the following questions. Evaluate the following and put your answer in a comment section. If you are yet to subscribe, ensure you do that right now. Like the video, share it with your loved ones. See you next class.